Hey y'all, so as promised, I'm going to do a video involving basically everything that we have to do with our lab up to this point, not including the graphing. The graphing is going to be done on a computer, so I could probably do like a Castify or something like that on it later, but I'm here by myself, so bear with me if well, yeah, Al's here, but he looks a little stiff. Anyway, so I really am, I'm here all by myself. So bear with me if the video is a little bit wobbly. I didn't bring a stand or anything. And in a little while, I'm going to prop it up literally on a ruler. I'm being inventive. On a meter stick on the computer, propping up to show the video part of it. So bear with me, like I said. All right, so here we go. If you haven't done so already, you should have, whoops. If you haven't done so already, you should have, of course, made your lab, or made your ramp, I mean. So the ramp that I have right here is just a piece of cardboard, and I propped it up on a couple of books, and you would go through and mark it at even intervals. I suggest 10 centimeters just because it's kind of a nice, easy way to do the math. So you would come up here and you would go 10 centimeters, 20 centimeters. It'd help if my marker actually worked. 20 centimeters, 30 centimeters, 40 and 50. So I have my 5 launch zones. So I would go back and do something like this. All right. Now I'm going to actually use the ramp that I actually have set up on the desk, but this is just to kind of show you yet another example of how to do it. I also had a lot of people say, well, I don't have anything that rolls. I don't have a ball. I don't have a marble. I don't have this. I don't have that. But if you could find anything, this is chapstick. If you find anything at all that rolls, anything that rolls, that you could roll down your ramp. So what you would do is you would start from here, you would let it go, and using a timer, and I don't have a third hand, so I'm going to pretend, I would go start, stop, and I would stop the time when it got to the edge of my ramp. Now I'm going to do it again. I'm going to write that down. Let's say it was 0.83 seconds. Now I'm going to do it again. Start, stop, and that's, I don't know, 0.9, so I'm going to write that down. And then again from the same place. Start, stop, stopping again, as I said, at the edge of the ramp. So once I have those 3 written down, I'm going to go ahead and move to my second launch zone, my 20 centimeter. I'm going to do the same thing. Start, stop, write that down. Start, stop, write that down. Okay, and again, 3. And then again from here, and so on. All the way until you get to the last one. Start, stop, start, stop. All right, so we're not measuring anywhere it's rolling or anything like that. We're just measuring until it hits the end of the ramp. So we're starting with our lowest number because it's only 10 centimeters from here to here. And it's 20 centimeters from here to here, and so on. Now, if you want to use different numbers, you may. Just make sure they're equally distanced apart. 5, 10, 15, 20, or 20, 40, 60, 80, etc. Just make sure you have 5 launch zones and they're all equally separated apart. And you have something that rolls fast enough and smoothly enough that it actually rolls well, but not so fast that you can't time it accurately. All right, now from there, hey Al, how's it going? I'm gonna go ahead and pop you up here and see if I can get, there you go. Okay. So here's the lab that I actually use to collect my numbers, and I'll show you my numbers here in just a second. But the first thing, especially if you were absent, that you maybe haven't done yet, is you open this from 10 to, it's in the, 10-1 in Google Classroom. And that's under today's to-dos in science, 10-1 in Google Classroom. So you'll find this document, your ball and ramp lab, it's hooked down at the bottom of that particular 10-1 assignment. You open it up and it looks like this. Put your name on it. The next thing is you're going to come up with an if, then, because hypothesis. Remember, if, then, because hypotheses are going to involve your independent and dependent variable as well as your reasoning. So my independent variable, the thing that I'm actually changing, I'm going to write first. So for instance, if the height of the ramp increases, if the height of the ramp, and I'm not talking about changing how steep it is, I mean moving up the length of the ramp here. So so I put the height, or maybe I put the length of the ramp increases, Then, so this is my independent variable, the thing I'm changing, the height or the length of the ramp, or where I'm going to drop my marble. Or you could say, if I drop my marble from a higher point on the ramp, or if, whatever, the thing that you're changing. Then from there, you're going to go ahead and write your then. So your then is going to be your dependent variable. What's the thing that's changing? What are we measuring? And that's going to be the speed, right? So then the speed of the marble or pencil or whatever you're rolling, marble will what? Will it increase? Will it decrease? You tell me. What do you think? Because, now this is where your logic comes in. So maybe you're going to say something like, because gravity works on all things the same. Or maybe you're going to say, because it'll give it more time to build momentum. Or because whatever you think it is. Because more friction will make it go slower. Whatever logic that you use, you're going to write here. So because blah, 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 period. All right. So that was the beginning of your lab. And that's where we stopped, basically on day one. Setting up, showing you how to run the lab itself, and then going from there. So now I'm going to go ahead and move up. Procedures are next. So I'm going to go ahead and measure with my meter stick or with my ruler the height of my ramp, where I'm going to drop the ball in from here. So I'm going to take my meter stick or my ruler, and I'm going to measure 5 centimeters. So 5 centimeters from the base to the tallest point of my ramp. So right here, I'm going to write 5 centimeters. That way, if something happens or my ramp falls down or I have to take it down, I can rebuild it exactly the same way. Okay, so then I have that. So we're going to go ahead and move on to filling this out with our data. So here I am with my marble, which is in my pocket somewhere. Found it. And I'm going to go like this. Here's my marble. I'm going to let it go. Start. Stop. And let's say my stopwatch says it's 0.83 seconds. Now I'm launching this from my 10 centimeter mark. It's my 10 centimeters. Whoops. I don't put units in my cells. It's already up here. So 10 centimeters. I'm going to do it again. Start. Stop. And let's say that one was 0.9, so 0.9. Now I'm going to do my third one. Start. Stop. 0.83. All right? Now I'm going to do that all the way across, and because I've already done this once, I'm just going to go ahead and write these in. So this is my distances up my ramp. 10, 20, 30, 40, and 50. My first time I launched my 20, I got a 1.11, and I'm not making these numbers up. I actually wrote them on the board over there so I wouldn't forget. 1.10, 1.20. So when I launched it from here, those are the numbers that I got. Okay? So then when I moved up and launched it from my 30 centimeters, I got 1.32, 1.39, 1.51, and then when I went for my fourth launch zone, I got 1.6, 1.59, 1.61, and then for my fifth one, I got 1.79, 1.80, and 1.76. Whew, that was a lot. All right. So now what? Now I'm going to grab my calculator. And I'm going to find my average time that it took for my marble to roll down the ramp. So the average time that I have, I'm going to look at each launch zone individually. So for instance, the first one I'm going to look at is the one that I launched from my 10 centimeter launch zone. So I'm going to find the average of just those 3 trials. So how am I going to do that? Well, in my calculator, and hopefully you can see this enough anyway, I'm going to go 0.83 plus 0.9 plus 0.83. See, I'm just adding this one, this one, this one, and I'm going to hit equals. Now I'm going to hit equals because if I just go and click divide by 3, it'll only divide that last number, and I need that sum first. So add these 3, bunk, 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 press equal, and I have 2.56. Now I'm going to divide that by 3 because I had 3 trials. 1, 2, 3 trials, divide by 3, and I got I just miskeyed, so let me try that again. One take wonder, 0.83 plus 0.9 plus 0.83 equals 2.56 divided by 3 equals 0.85333333. So 0.85. And I don't have to write seconds because, again, that unit is already up there. All right, so I'm going to go ahead and do all of these really quickly. So here I go. I'm going to do it again. Now I'm going to do this one all the way across. So I'm going to go 1.11 plus 1.1 plus 1.2 equals 3.41. Divide that by 3 equals 1.14. I'm going to round that to the nearest hundredth. I'm going to go 1.32 because now I'm going to do this one right here. I just did that one. 1.32 plus 1.39 plus 1.51 equals 4.22. I'm going to divide that by 3 because there are 3 trials. 1, 2, 3. And I'm going to get 1.41. 1.41. All right. Now I'm going to do the next one, 1.6. I'm going to take this, I'm going to add with that one, plus 1.59. Whoops, I just miskeyed. 1.6 plus 1.59 plus 1.61 equals 4.8. Divide that by 3 equals 1.6. 1.6. Now I'm going to do the last one, and that's 1.79 plus 1.8 plus 1.76 equals 5.35. Divide that by 3 equals 1.78. 1.78. So again, all we did was add straight across, divide by 3. 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 All right, so far so good? Okay, that was the first part, the first step. Now we're gonna go ahead and compute our speed. So far, all of these are our average time it took for the marble to roll that specific length. So it took an average of 0.85 seconds to go from here to here. It took an average of 1.14 seconds to go from here, our second launch zone, and down. It took an average of 1.41 seconds to go from here down, 1.6 seconds to go from here down, and 1.78 seconds to go all the way from here all the way down. Now your numbers are going to be different because even if you have the exact same setup as me, and you're using a cardboard ramp and a marble, it's going to have different textures. It's going to have different frictions slowing it down. It might even have a different inclination. So don't worry if your numbers don't match mine. That's okay. All right. Now we're going to compute for speed. So what is speed? Speed is distance over time. So things that you'd be familiar with would be things like miles per hour or meters per second or kilometers per hour. Today we're going to be looking at centimeters per second. So here we go. Centimeters are going to be our unit of measure per second. So we're going to go ahead and look at the first one again. So we're going to look at the first one and it's going to go like this. What's my distance? Where's my centimeters? These are seconds, these are seconds, these are seconds. Here it is. Okay, here's my distance because my distance between my launch zone and the end is 10 centimeters. So I'm going to write 10. 10 what? 10 centimeters. Now, what was my average time that it took? My average time was 0.85 seconds. So I'm going to divide that by 0.85 seconds. Now that kind of looks like a hard thing to do. There's decimals and fractions. What are you doing? Remember, when you're looking at a fraction, what that line means, simply means divide. So first we're going to go ahead and get rid of these units of measure. We're just going to pop them right here and go centimeters per second. And I'm going to use my calculator again because why not? So I'm going to go ahead and turn my calculator on right here, and I'm going to start by keying in the numerator. That's the number on top. 10 divided by 0.85 equals, there you go, 11.76. And I'm just rounding it to the nearest hundredth. So 11.76. 11.76. 11.76 what? 11.76 centimeters a second. So if that marble continued at that same speed right here, it would travel in 1 second 11.76 centimeters. So now let's go ahead and do the next one. Again, we're going to look, let's erase this. Now I'll leave that there, give it some sink it in time. What's my distance? 20. I know it's 20 because it says so right here. That's my second launch zone, 20. 20 what? 20 centimeters. I'm going to divide that by my average time, which is my 1.14 seconds. 1.14 seconds. Again, I'm going to take my centimeters per second. I'm going to throw it right here, centimeters per second. I'm going to use my handy dandy calculator, and I'm going to key in 20 divided by 1.14 equals 17.543859. I'm going to round that to the nearest hundredth, and I'm going to go 17.54. 17.54. 17.54 centimeters per second. I'm going to go ahead and do the next one. 30, because I know I've got my 30, so I'm just going to go ahead and key it in. 30 divided by 1.41. 1.41 equals 21.28. 21.28 centimeters per second. And now I'm going to do the fourth one, and the fourth one was 40 centimeters. So 40 divided by 1.6 equals 25. Nice whole number, 25. 25 what? 25 centimeters per second. So now finally, I'm going to do my last one, and that was 50 centimeters divided by 1.78 for my average time, and I'm going to end with 28.09. 28.09 centimeters per second. So I've done my lab report up through number 8, saying calculating my average speed. So here's my average time, here's my average speeds. Whew, I'm done, at least for the weekend. All right, on Tuesday, I'm going to show you how to graph this stuff. All right, but for right now, this is what we've got. So if you were absent or if you were confused, you can feel free to use my numbers. All right, feel free to use my numbers. But I want to make sure that you understand how you came about getting those numbers. All right, so feel free to pause, rewind, and watch again as many times as you would like to get this concept in. Our speed is always the distance our marble traveled divided by the average time it took to get there. And that's our speed. So thanks for joining me. I know this was long. Thanks for hanging in there. See you Tuesday.